The certification tests really ask you to take a broad overview of the platform and understand how the pieces and the capabilities provided on the platform can be used to fit together in order to deliver a solution for a customer.
Certification proves that an engineer not only has that real-world experience, but also has the technical knowledge to be able to be certified and to operate at the level that is required.
What certification offers that experience doesn't is peace of mind. I'm not only talking about self-confidence, but also for our customers. Having us certified working on their projects really gives them peace of mind that they're working with a partner who really knows what they're doing.
Hey everyone, my name is Albert Vu. I'm here with Louisiana State University, and I'm super excited to walk you guys through this lab today. We're going to be going over load balancers on GCP. And before we start that, I do want you to pull up this link. It's called bit.ly/GDSC 30 days 1. This is going to be how you're going to get access to the platform that we're going to be using today called Quick Labs. Normally it costs money to provision these cloud resources, but if you go to this link and you click Start Lab, I can't start it myself because I've done it a few times, but you want to start that lab, let it run for at least 5 minutes. The timer should go under 40 minutes. And then you're going to want to click End Lab at that point. And if you click End Lab and refresh, and you click on your profile, you should see this monthly subscription on your profile. Very important. You're going to need that to do all the stuff today. So while you let that tick down, I'm going to talk about some other cool stuff. The next link you want to go to is cloudcoach.dev. This has a ton of stuff. First thing it has is this leaderboard. This leaderboard tracks people who have registered on this site, and it tracks people from different colleges, the badges they've earned. You can see all the different schools, all the different participants. And something cool about this is actually how you unlock funds for your chapter. So really make sure you sign up for that. If you want your chapter to get funding, maybe you'll get some cool swag later. Who knows? Definitely do that. On this site, you can also watch the live stream right here. And there's this community space button, which will bring you to this website called Kumo Space. Kumo Space will let you join these various lobbies where you can interact with people, talk to them. There might be people that can help you answer questions. It looks like this. Basically, it's kind of cool. You can move around and people won't hear you until they're inside your little bubble. And I think they won't see you either, your camera at least. But after that, you're going to want to go over to go.quicklabs.com/hey-student. And this is the site that we're going to use to sign up for our track if you haven't, and how we're going to access our Quick Lab for today. But I'm going to wait a little bit to make sure anyone that hasn't gotten their monthly subscription from this lab gets a chance to actually have it so they won't fall behind. Let me know if you guys need more time or if everyone has their subscription ready. Part of this one. It's fun. All right, so I'm gonna go ahead and just start. It is recorded, and I'm not gonna go super fast. So if you need me to slow down, feel free to type in the chat, ask me to slow down, or ask me to clarify some things. I really don't mind. So I'm gonna go ahead, and on this site, I'm gonna click enroll. And it's gonna open up. It's gonna ask for a code. Don't worry about it. Just click cancel, because you have the subscription, so you don't need a code. All right. And once you're on this page, we're going to scroll down all the way to this use Google Cloud to build your apps. Once you're here, you're going to scroll even more down until you see the lab for today, which is setup, network, and HTTP load balancers. And you're going to click on that. And once you're here, you can go ahead and click Start Lab whenever you want, and you can click Use Subscription. Normally it costs 5 credits, but we have that subscription from earlier. And once you click Start Lab, right now they're provisioning a Cloud IAM identity for us, and we're going to use this to log into the Google Cloud platform. So what you're gonna want to do is you're going to click Open Google Console, but you're going to grab that link, you're going to copy that link, okay? And you're going to open a new incognito window and paste it into there. The reason for this is sometimes your accounts might get a little mixed up, so you want to have it fresh on a new incognito window. All right. Okay. And you're going to log in with these credentials that are given to you. It should autofill the username for you. Go next here. Paste the password in. Make sure you're using your own here and not mine. Okay. And it's going to log you in. All right. And everything's loading. Okay. And once you're logged in, you're actually going to see this. This is the project we're in right now. And just make sure that matches up with the project ID right here. So mine matches up, so I'm good. I don't have to worry about that. And you're going to want to open up the Cloud shell. It's going to be in the top right for you. It's going to be this icon, or if you're on a smaller resolution, you're going to have to click on the drop down, but just click Activate Cloud Shell. And it's going to pull up like a console that you can use to run all the commands we're going to be doing today. Just let that load. It's going to take a little bit of time. All right, I'm going to make this bigger for you guys. And before we start today, let me show you a little image here. So this right here is the basic concept of load balancing if you're not familiar with it. It helps with availability and not overloading your resources. It's exactly what the name sounds like. It helps balances the load. So if you have multiple people making requests to one like IP address, one website, it's gonna use some kind of algorithm that you set. There's various methods of load balancing, and it's gonna direct it to the proper resource. So right here, you can see that the first request goes to the first server, and the second request goes to the second server, rather than just all going to the same server, right? And if you have like millions and millions of requests, it's gonna be bad. Some of them might get too underload, and you're gonna see this a lot in industry, working with APIs or websites. So definitely very important to pick up on. So I'm gonna go back to the lab though. And the first thing you're gonna wanna do, you're gonna scroll down all the way to task 1. And right here, we're just gonna set our default region and zone. So on cloud providers, regions contain zones, and regions are basically different, I guess, areas where resources are hosted. And this is important because some resources on the Google Cloud platform, they're restricted to maybe its own region, and some stuff is restricted to its own small zone. And if you make stuff on may you repeat what it, okay. So when it asks for a code, you just want to click cancel, provided that you have a monthly subscription. And if you're confused on how to get a subscription, I can run through that real quick too. But basically, we're going to set a default region and zone, and that's where we're going to make all our resources for today. Because if they're on different regions and zones, you might not even have access to them. And when you run this command, you're just going to click authorize. Project is not currently set. Interesting. Wait. Okay, so if you get this error, I guess just run this command right here. I've never done this before. It's kind of weird. And you're going to run that with the project ID. Let me grab that up here. And this is just going to set the project in the Cloud Shell. All right, yeah, see updated property core project. Oh yeah, and I can see my projects right here now. All right, scrolling back down, I'm gonna set my default zone and my default region. So all the stuff we make today is gonna be in that region, the bigger one, in that zone, okay? Let me run this. All right, and once you see that it updated our properties, we're gonna scroll down, I'm gonna do some more setup. So here, task 2, we're gonna be creating multiple web server instances. So remember in that picture I showed you, these servers, we're gonna be setting those up, and those servers are gonna be the ones that are handling our requests, right? So right here, they're actually going to create 3 separate VMs, virtual machines, and they're all going to be pretty much identical for the most part, but they're going to have a different name. One's going to be named www1, www2, www3, and I'll walk you through the command. It is a little big, so as you can see here, gcloud compute instances create. So we're creating that instance. We're naming it www1. We're giving it some information so it knows what to do. So this Debian cloud, like what to use for that VM, like what it's running on. As you can see here, the zone we set here, same zone that we set the default zone to. And this tag, so tags on Google Cloud, it's really just exactly what it sounds like. It's just a name, and you'll see where it comes into play later, but all of them have this network 1B tag. And then this script that's on each of them, this is actually installing something called an Apache web server, and that web server is just going to print this basic HTML for you. And we're going to use this later. That's the gist of it. Any other questions, just ask me. But I'm going to go ahead and create our 3 VMs. So big commands. I normally recommend typing stuff, but as long as you understand, it's okay to paste these in, save some time. And it's going to take a little bit of time to start up each one. But once you start up one, you can actually see that it says it's running. We have these IPs, the name of it, www1. You can see the okay, yeah. And this external IP is what we're going to use to actually access each one. You'll see that later. But let me start up all 3. We want all 3 of our VMs up. And these VMs, again, are going to be the servers that serve our requests. Any questions so far? Let me know if I'm going too fast, too slow, just right. All right, and so now, once again, we have our 3 VMs running, our 3 servers. And we're going to create a firewall rule that allows external traffic into the VM instances. So when you're working with cloud services, you're going to have to set security rules for everything. So these VM instances, initially, they don't allow external traffic, but obviously it's going to need to be able to accept traffic because they're going to be the ones accepting our request and serving them, right? So we run that. We allow TCP/80. Okay. And notice here, it's actually targeting this tag called network 1B tag. And remember what I said earlier, how these tags are attached to each one of our VMs. And so we run this once, and it'll update the firewall rule for all 3 of our VMs because it updates on that target tag. Pretty nifty. And okay, so now if we run, I'm gonna type this one out, it's pretty short, just to get into the habit, right? G-cloud compute instances list. This is gonna list all 3 of our VMs we made, and you can see these external IPs. So we're gonna try to curl, which is used to grab data, it's making a request. And we're gonna curl, you can pick any one of them, but pick one of the external IPs on any of your 3 VMs. So I'm gonna use my last one. And if I curl that, you can see that it outputs this HTML, and this HTML contains www3. So that's working. We can grab data from our VM, and it serves our request. All right. And important here, after you're finished with all these steps, click check my progress. Make sure you get that green check. If you don't, let me know. You might just have to rerun some of the commands. You might have mistyped something or skipped over one of them. But you're gonna want all these green checks. So at the end of the lab, it's gonna say 100 out of 100, so you can get that badge. All right. And now we're gonna actually get into the actual load balancing service. So here, we're creating a static external IP address for our load balancer. And it's going to be called network-1B-IP-1. And it's going to be located in the US Central 1 region. So this external IP address, you can think of this like, let me pull up the picture. So that external IP address is the IP address of our load balancer. We're going to slap it onto our load balancer right in the middle there. And that's going to be how clients or users access whatever resource you want, whether you're working with an API and you want to hit an API, you're going to hit this load balancer. Or if you're navigating to a website, like if you're going to google.com, google.com doesn't just have one server that serves every single web page, every single user, right? But you're navigating to the same URL, that google.com, and that's going to be what our external IP is. That's going to be how people access the resource that they want. So I'm going to go ahead and create this IP. All right. And also, some more setup, we're going to create a health check. And I can explain the reason for this later, but real quick, so a health check, exactly what it sounds like. It makes sure our instances are healthy, and you're going to see how that comes into play on step 3, actually. So step 3, we're going to create a target pool. It's going to be called www-pool, and we're going to slap the region on it and the health check that we just made in the previous step. And once I go through these few steps, I'm going to step back and explain it again, just in case, so you guys get what's going on here. I know it's a lot of commands, but you'll understand in the end. So once we have that pool, we're going to add our instances to the pool. So think about it. We just made like a little bucket. That bucket has like some stickers on it, some like configuration, right? And in that bucket, we're going to toss those 3 VMs that we made earlier into there. Okay? And you'll see why. Some of you might already have an idea of what's going on, but so going back to the infamous picture, what we just did is we made a target pool. So a target pool, if you want to imagine if I drew a square around this side right here, our servers, right? And it's like our bucket, okay? And the load balancer will, when serving a request, just grab one of the VMs out of that bucket. It's going to grab VM1, VM2, VM3, either of them, depending on what we set up, right? There's different methods of load balancing. I'm going to show them real quick. Stuff like round robin, IP hash, least connections, least response time, these spam lists. Some of these might be weird. You don't have to memorize these just yet. I'm just letting you know that load balancing isn't just, there's not just one way to do it, right? You can set it up to, for example, your load balancer sends to the server with the least response time or something like that. That's just something to keep in mind, really. All right. So now we have that bucket with all our instances in it, and we're going to create a forwarding rule. Okay. And this forwarding rule is like kind of like the core of our, it's like the first step in our load balancing process. Anything that goes to this address, this network 1B IP1, which is that external address we made earlier, right? So this command is saying anything that goes to this load balancer, it should be directed to this www-pool that we just made. So anything that goes to this load balancer is going to go to our pool. Does that make sense? And I'm going to run that. It's going to take a few seconds. And once that's done, we're going to click check your progress again. And you should get some more points for that. And there we go. So now we have our VM set up, right? Our servers that actually serve the requests. We have our load balancer set up, and some rules that direct things from our load balancer to our VMs. But I'm sure you guys want to actually see that in action, right? So now we're going to send traffic to our instances, and we're actually going to be able to see everything work, okay? This is going to be pretty cool. So let's just make sure you have this forwarding rule up, and we're going to use this command, this describe command on that rule we made, okay? And we're going to do this so that we have access to our external IP. And the reason for that is we're actually going to request stuff from that IP, okay? So this next command, while true, do curl -m1 and then our external IP address, and then done. So this is just going to repeatedly go to that external IP address over and over and over and over. And when you run this, you're going to see something cool, okay? I'm going to type this one out. It's short. Give you guys some time to catch up, and feel free to ask any questions. I'll try my best to answer them. So type this command, and from that previous describe command we ran, you should see this IP address. So replace that with your IP address, the external one that we made, and done. Again, as you can see, this is over and over and over, we're getting the content that's served from that Apache web server on each of the VMs. But if you look closely, you can see that we're actually getting stuff from all three of them. We're not just hitting one of the VMs, right? Like, as you can see, we're getting www1, www2, www3, and this is the load balancer in action. It's rerouting our traffic to our different VMs so that generally we want the VMs to take like equal loads somewhat, right? So they don't get overwhelmed. And yeah, that's pretty cool. So I'm gonna click Control C here to cancel that. You want that to run forever because there's still a little more to the lab. So what we just set up is a network load balancer. There's two different types of load balancers, one called network, one called HTTP. And they actually both work on different network layers. There's some specifics to it, but the one basic difference I found was that the network load balancer only works within a specific region, that IP address, but the HTTP load balancer actually works cross-region, and you're going to see that later when we go through it. We're going to be setting up like a global IP instead, global external IP, and this might be useful, for example, like that Google.com example I mentioned earlier. It's gonna Google when you go to Google.com, there's gonna be a load balancer cross region that's gonna reroute you to a close proximity server, right? Like if you're in the US, you're not gonna be accessing Google.com with a web server located in Asia. There's gonna be higher latency, all that. So pretty sure this is used for that. There's more to it. We can talk about it later, but let's go and set up this HTTP load balancer, which is going to be similar to the other one, but there's going to be a few more steps. There's just going to be a few extra steps in the middle, and let's get started. So we're going to run this command, and this command is going to make a load balancer template, okay? And it's going to be called 1b-backend template. And just a bunch of metadata, okay? And then it's going to run another script, and our web page will say page served from, and then the corresponding VM, okay? And let's go ahead and make this template. And then after we make that template, we're going to make a managed instance group based on the template. And I'll explain what's going on here after I run these two, okay? All right, once your template is created, we're going to use that template. As you can see here, we use that template, 1B backend template, size 2. So we're only going to have 2 instances this time. And we're going to run that. Okay, so while that runs, I'll explain how this is different from the previous one. So with network load balancing, we set up those 3 VM instances, right, manually, and then we threw those into a pool. Okay, that's just network load balancing usually uses target pools, but HTTP load balancing, it usually uses something called an instance group. And how that differs from a pool is instance groups, they're more like they treat several VMs like one whole entity, right? But the target pool was more like 3 different VMs floating around in the pool, if that makes sense. And not sure why, but that's just what's required for each of the load balancers, okay? So you're just going to want to remember that when you make an HTTP load balancer, we're going to want a instance group. So I'm going to continue on. Now we're going to add a another firewall rule, and this rule is so that it allows traffic from Google Cloud's health checking systems, and it uses this tag allow health check to identify the VMs. If you scroll up, you can see that our VMs were made with allow health check. Remember, we made these VMs, this instance group, based off this template. So they're both going to look like that template. So let's go ahead and run this firewall rule. Just give it access here. And while that's working, look at the next step. You remember when I talked about this? Here we're creating a global static external IP address that customers use to reach your load balancer. And if you remember, or if you scroll up previously, that external IP address we made last time was not a global static IP address. So this one will actually be cross region, if I recall correctly. So let's make that. Similar concept to the other one. And this command, this describe, we're going to describe the IP address we just made, just to make sure that we have it reserved. And we can see what it is too. Right there, 34.120.238, yada, yada. Okay? And once again, we're going to create a health check for our load balancer. Health checks, these just make sure that these check on the instances, right? Because, we have like a pool of instances or an instance group of instances. Generally, you're going to want those to be healthy. Like, you don't want to send requests to unhealthy instances. Something's wrong with them. This health check keeps track of which instances are healthy or not, and we can do stuff based on that, right? Generally, it's not going to send requests to unhealthy instances. So now we're going to create a backend service, and then we're going to add our instance group as the backend. So kind of making like a bucket here, like a backend service bucket. And then the backend service bucket, like the brain of it, is going to be that instance group, the thing that's actually inside of it that's serving the requests. Somewhat similar to the target pool, all right? But instead of a pool with individual VMs, we now have a backend service that contains a instance group. Health checks help us understand and we should take from the pool, or is it like a guard that stops from being picked? It actually, I think it's more like a guard, if I remember correctly, because I remember earlier we only set up one pool. We set up that rule that directed from our load balancer to that pool, so we only have one pool, right? So if there's no other pools to direct to, that'd be an issue. So it looks inside that pool, and we had VM1, VM2, VM3. You know how we were randomizing, going between 1, 2, and 3. Say VM3 notify the health checker when it called it unhealthy. If it's unhealthy, our results are only going to say VM1, VM2, VM1, VM2, right? Yeah. All right, cool. So now I've made the health check. So now I'm going to create this backend service. And once again, we're going to put our instance group inside of that backend service. And all the tags here, just more metadata. If you want me to explain any of them, I'm going to try my best. But it's just setting stuff up, like what protocol to use, which health check to use, global instead of like a region that we had previously, right? Okay, so I'm gonna stop right here. It's a little confusing. Like I'm gonna scroll up and down. You're gonna see like there's a bunch of random steps. You're probably putting these in. You probably have no idea what's going on. So something I noticed here, we're actually working like bottom up. It's kind of going backwards. So I'm gonna scroll down to the last step, and I'm gonna explain starting here. Okay. So this is how an HTTP load balancer works. It starts at this global forwarding rule. Last time we had a forwarding rule, this time it's global. And this global forwarding rule, it's going to route requests to something called an HTTP proxy. Okay. Not sure the details on that. You can look it up. Just treat it like an extra step, just another step in the process. And this proxy is going to once again route to something called a URL map. Okay, just another step in the process. And then, as you can see, the URL map will route to our backend service that we just made. And from the backend service, it's going to use that instance group to serve our requests. Okay, it's a few more steps than the other one, but it's a similar concept. You just start at the forwarding rule, and you just route and route and route until you're at the VM that you want to use to serve your request. And that managed instance group, it's managed by Google Cloud Platform. It actually has its own little load balancer in it, right? Like, you know how I said that we treat it as one big entity? Like, we treat it as one thing. We don't have to specify the VMs inside of it. But when it gets to that one thing, Google Cloud does its thing since it's managed, and it directs it to the right VM inside of there. And we have 2 VMs inside of there. All right. So I'm going to go ahead and start running the commands again. But let me know if you want me to repeat that or clarify something. All right. So we have that backend service. And now I'm going to create the URL map I was talking about. And this URL map routes to our backend service. Okay. And the reason they work bottom up here, they work backwards. It might be a little weird. You might be wondering why. I mean, if you look at the command, right, to create this URL map, we create a web map HTTP, and the default service is web backend service, right? So we can't run this command if there's no backend service already created, right? And similar logic follows for all of the other steps, really. Okay, so that's why they do that. It might have been a little confusing, but yeah. Again, we're going to create our proxy, and this routes to the URL map. And then we're going to be at the last step, aka the first step when serving requests with load balancing, is creating the forwarding rule. And the forwarding rule, if you look at it, it's kind of similar to the other one. There's an address, how people access it, and there's a target. And the target this time routes to the proxy, which is step 9, which routes to step 8, and it just goes down the chain until you reach the server that you want to serve your request to. All right. And so you're going to want to click check my progress, but I think you might have to wait like a minute or two. Yeah. So wait like a few minutes here. I'm going to pause, take a sip of water, and if you guys have any questions, now's a good time, because this takes a few minutes to update. So don't fret if you get an error right here, because I'm getting one too. All right, let's see. All right, and as you can see, if you try again, you should get assessment completed. And we have 100 out of 100 here. But one more thing we want to do. Okay. Yeah. Okay. Very important. Make sure you have 100 out of 100 once again, so you can get that badge at the end. But don't end the lab just yet. You are done. You have set up a network load balancer successfully and an HTTP load balancer successfully. But once again, we're going to want to test sending traffic to the instance because we did all that work. We want to see it in action, right? So let's go ahead and go to step 6. This is an easy one. Don't worry, guys. So from here, okay, I'm going to actually close my Cloud Shell. I don't think you need it anymore. And on the Google Cloud Platform, you're going to want to go to Navigation Menu. You're going to scroll down to Network Services. Network Services. And the first one, Load Balancing. All right. Open that up. And once you're there, you can actually see some different things that we actually made in the Cloud Shell. Kind of cool, right? You can see our load balancing, our pools, stuff like that. Notice how the backend for our HTTP load balancer is a backend service, like we discussed, and our backend for the network-based load balancer is a target pool. Remember? But we're going to test the HTTP one, so you can just click on that. And they want us to scroll down. You can see our backend. You can see that it's healthy, 2 out of 2. Remember that template? Use that template. We created 2 VMs. So our managed instance group has 2 VMs that are both healthy. So that's perfect. We want to make sure they're healthy. And then we're actually going to try going to the load balancers. So if you scroll up right here, you can see this is the global IP that we made, right? We attached this to the load balancer. If you take this IP actually, and you open it up, http:// that IP address. There you go. You're going to see that it serves content from our backend, one of our VMs inside the backend. And it says right here, page served from 1b-backend-group-fc4x. And why don't we go ahead and try refreshing here. If you refresh, you're going to see that this time the page is served from 3D8V, right? So even though we're going to the same IP address, this 34.120.238.248, it's going through all those steps, and the VM that's being used at the end is different. So traffic, if you just keep refreshing, you see that it's going to randomly pick from one of those two. And there you go. That's load balancing in action. So once you're at this step, you are done. Congratulations, guys. You can go ahead and close out of your cloud stuff and click End Lab. But I'm going to wait like 2 minutes just to make sure there's not any questions so I can still have access to it, pull stuff up. Any questions, comments, concerns? All right. Well, if there are no questions at all, you can go ahead and lab. And that's it for today's lab, guys. Congratulations. You set up a network in HTTP load balancer. Be sure to tune in tomorrow for a cloud infrastructure workshop hosted by Princeton University. And if you have any other questions, feel free to reach out to me, I guess on LinkedIn or something, if you have any questions about this lab that come up afterwards. Yeah, thank you so very much for attending today. Have a good one.
Hi, I'm Priyanka, and welcome to the module Where Do I Store This Stuff? In this module, you will see how you can take advantage of managed storage and databases for cloud applications. So far in this course, you've learned what GCP is, why you should have a solid platform before beginning a GCP transfer, and how GCP supports the building of apps. In this module, you will learn about storage and database options in GCP. The objective of this module is for you to be able to implement a variety of structured and unstructured storage models. To achieve this goal, you will need to meet the following learning objectives. Discuss the different storage options that exist in the cloud. Differentiate between structured and unstructured storage in the cloud. Compare the role of the different cloud storage options. And explore the use case for relational versus NoSQL storage. You'll also describe leveraging cloud storage as unstructured storage, and explain relational database options in the cloud and describe the NoSQL options in GCP. These are the topics that make up the module. First, you will learn about the different storage options available in the cloud. Then you will see the difference between structured and unstructured storage, and how you can leverage unstructured storage using cloud storage. A hands-on lab will allow you to explore a range of activities applicable to cloud storage. You will then review the use case for SQL managed services. Next, you will explore Cloud SQL, and then complete another lab where you will import data into Cloud SQL and perform basic data analysis. You will discover how to leverage Cloud Spanner and explore the available NoSQL options. You will then learn how to use Cloud Data Store as a NoSQL document store. You will complete the module with an app development activity that requires you to store app data in Cloud Data Store. And then you will learn how Cloud Bigtable can be leveraged as a NoSQL option. The module will end with a short quiz and a recap of the key learning points covered in the module.